Okay, good morning, everyone. My name is Hugo Gaglioni. I am with the Imaging Products and Solutions Group of Sony North America. And I'm going to try to give you some information on the ecosystem that Sony has developed for the production of HDR and live applications. As you probably are aware, there are a range of different applications for image production, all the way from large-scale production for cinematographic projects, very expensive, very high quality, and most of the processing is done in non-real time, in post-production environments. And in the case of live productions, we have, again, very high budgets, very high picture quality, but everything has to be done in real time. There's no possibility to do post-production color grading in non-real time environment. And there are other applications where the level of picture quality is not as high, not as demanding as what we find in the large budget production, such as in wedding videography, lower budget. And those are lower cost, lower budget production. Sony has developed, for each one of these classes of images, different classes of HDR environments. In the case of cinematography, we have a file-based production where we use the raw signal from the cameras, also the XOCN signals that we have in the Venice cameras in high cinematography. In live production, which is what I'm going to explain in more detail, we call this system, the commercial name that Sony has is called SR Live, and I'll explain that in a few minutes. We use two gamma curve or logarithmic curve for capturing the images. One is the S-log3, the other one is hybrid log gamma. And in the case of semi-professional, consumer-based applications, these operators, they don't have the knowledge, perhaps, or they are not interested in the complexities of HDR production, and they just simply they want to press a button and record something that has HDR quality. Probably you have seen this document. These are international standards produced by the ITU, the International Telecommunication Union. This document, the 2020, describes the parameters of ultra-high definition formats, such as 1080 progressive, 4K, 8K, and the color space is the color space 2020. The Standard 2100 describes the use of a logarithmic curve for HDR. We have the PQ signal and the HLG signals. They are fully described in that document. And recently, last year, there was a very important document, 2408, that describes the guidelines for practical television production in HDR. Then this document, in particular the 2100, describes two classes of HDR production signals. One is the PQ, or perceptual quantizer, that defines the EOTF, the electrical to optical transfer function. That's the standard that has to be implemented in the display, whether it's in your television at home or in your master monitor in a post-production house. That's where the EOTF has to be implemented. The HLG, the hybrid low gamma, is a standard more related to television practices, and that curve, the OETF, the optical to electrical transfer function, is implemented either in the camera or in the point of origination. The Sony system, the Sony ecosystem, is called SR Live. SR means seen refer, as seen by the camera. All the production is based on processing signals created by capturing the light. This is a typical production environment, whether it's for a studio or for outside broadcasting. The center portion is the production environment. It has to be 1080 progressive or 4K in color space 2020. And we have selected, Sony has selected in our product, S-log3 or HLG in production. Then the signals that are feeding this environment, some of them could be 2020 color space with high dynamic range from our cameras, but in other cases, they may be legacy material. It could be 709 color spaces, a high definition interlace. Therefore, there is a need for a layer of conversion between these input sources and the processing environment. Once the program is finalized, then you're ready for distribution. And again, we have to convert from the production environment to the distribution HDR curve. And we have two, PQ and HLG. And as well as we have to produce a very high quality SDR. We cannot compromise the quality of the signal that pays the bills. Then this is essentially the workflow that we have with our cameras. These are all state-of-the-art cameras from Sony, and I'll show you more in a minute. Our CCUs, the camera control units, produce simultaneously HDR signals and SDR signals. Then the shader, we are recommending that the camera operator, the video engineer, shades or paints the camera looking at the SDR signal. Why? Because that signal cannot be compromised. You cannot create artifacts on the SDR layer. Then the operation of painting will affect the layer of HDR, and then at the same time you will be producing an HDR signal and an SDR signal with excellent quality, each one of them. This is a very advanced processing device that Sony uses in studios as well as in outside broadcasting trucks. It has capabilities for up to 8 channels of 1080 progressive or 2 channels of 4K, and it's a Swiss Army knife of conversion. It can convert 709 to 2020, HD to 4K, 4K to HD. It has all of the gamma curve for HDR production. This is a very important device in the whole ecosystem. Then scene refer. As I mentioned, this is a philosophy, it's a perspective of processing, considering what the camera is capturing. I'm referring my processing to maintain the quality captured by the camera. Scene refer. The video engineer, once again, is shading the SDR monitors. The HDR signals will follow all of the actions of shading in SDR. You transmit the signal to your home. The SDR quality that you get in your house is the same as the quality that was produced in the truck. Games, sports, live applications, entertainment will follow this workflow. The cameras will be feeding the HDR layer into your live production environment. The CCUs will output the SDR so that the video engineers will shade. And the conversion devices will produce simultaneously the HDR feed and the SDR feed. We have used this technique during the last 5 years multiple times around the world. And we had a very, very large degree of success, culminating last year we did the World Cup. Completely, the whole origination of the FIFA World Cup was done in HDR using Sony equipment in 4K as well as in 2K. All right, this is the family of, until recently, the family of television cameras that we have in a studio, from very low cost but very high quality HD, all the way to super high frame rate, capable of doing 8 times slow motion using the 4800 in 4K. Also the 4300, which is the de facto camera in sports for high frame rate, super slow motion. At the show, we're introducing a new camera. This is the first camera with global shutters. This is global shutters in 4K. Very, very important. In the past, that technology didn't exist, and this is the first, and there are other cameras that we're introducing at the show with this new technology of global shutter of the sensors. Then all of these devices, the new cameras, the POV cameras for Steadicam operation, all of these cameras are designed to support HDR. And their corresponding CCUs output 3 classes of HDRs, S-Log3, HLG Live, and HLG. This is what now is the signal into the production environment. All right, what are the challenges that we have encountered in the last 5 years? Well, one of the challenges was the following. The CCUs, baseband processing units of our cameras output, as I said, simultaneously HDR and SDR. But we have because SDR clips at about 100 nits, while the HDR can go all the way to more than 1500, we have to insert a differential gain. It's like a volume control. I'm going to lower the light level into the SDR path, and that differential gain has to be kept constant among all of the cameras in the stadium or in the studio. Then the video engineer will tell you, or will ask Sony, well, what's happening if my camera is pointing at a very well illuminated area, or another camera in the stadium is pointing to a dark area? Then I feel like changing that value. If I don't do that, my HDR is going to look very weak. We understood that process, and at this show, we are introducing a new software in our CCUs that permit individual painting of the cameras. We can alter the shadows, we can alter the midtones, we can alter the entire dynamic range of the camera without modifying the value of gain differential. This is a very important upgrade of our camera, and is now is resolving an issue that existed in live production. Okay, that's one issue. The other issue that we were actually, it's a challenge given to us by a very important network. This network is recording HDR programs going from a stadium to a stadium, following different football teams. And the camera signals are feeding the HDR into their servers. Maybe they were shooting a football game last week, then they were shooting another game 2 days ago, and that server is populated with files of HDR. And then at halftime, let's say, they want to create a compilation reel with highlights of the different shootings. Then when you have the HDR files, there's no problem. It looks fantastic, whether you're mixing scenes from last week, Monday Night Football, no issue. The problem is when you create the SDR signal, because the conversion box have no idea how the cameras were shaded last week or 2 days ago. Therefore, I cannot create a proper SDR from my HDR files. Then the solution to that problem is Sony is introducing a metadata packet that we are demonstrating here on the show floor. The camera is producing a full array of parameters of metadata that will go through the entire network of cameras, and that information goes into the header of the MXF file. Frame by frame is changing. Then when the conversion box is creating the SDR signal from the MXF HDR file, it will change dynamically the signal according to the parameters of metadata. This is a very important feature for live production. Another challenge that it existed primarily in Asia, but we are beginning to see it here, is the following. We have an HDR service, for example, in Japan or in China, and then you have your commercials in SDR, and you have your main program in HDR. The TV set will have to change gammas. The EOTF will have to change to match the SDR or HDR characteristic of the program. And we were thinking sending a flag in the HDMI. 709, give me the 709 gamma. HLG, give me the HLG gamma. The problem is, when you tell a consumer television to do that, the switching of the gamma will produce artifacts. Sometimes it's 3 frames, 4 frames, it may go black, it will be freeze. Therefore, that didn't work. Then what we've done is, especially consumer manufacturers, this HDR service is now completely set in HLG. The broadcasting is all the time, 24 hours a day in HLG. And then we send the SDR signal, disguised as an HDR signal. Therefore, the TV doesn't have to change the gammas. The question is, how do I change my SDR content without changing the creative look of the commercial, the original look of that commercial? In other words, that SDR commercial has to look the same in your HDR display. Well, It's getting a little bit more complicated, but this is a processing technique that we have in live production when we match SDR cameras with HDR cameras. This is the gamma, this is the linear light that we are capturing. You have the gammas that we produce, the 709, for example. We invert that gamma, and we go back to linear light. And this is how we match the HDR cameras with the SDR cameras. And then at the output, we place whatever is the HDR curve for production. That is for live production. For the commercial, we use a different technique, display refer. Now, I have a commercial. It can be a legacy commercial, 709. I will invert the OETF of that commercial, and I will recreate how that commercial looks in my screen. Display light. And then that display light is how that SDR commercial looks like. And I need to get it all the way to my house. Then I will cancel the operations in my TV set at home before I transmit. Then those two blocks will cancel the operations of my TV. By doing that, you are transmitting an SDR commercial inside an HDR transmission channel, maintaining the creative look of the commercial. Then these are documents available as guidelines for television services. If you are in the truck, if you are in your broadcast center, you are in the master control of your broadcasting center, you have to respect certain conversion guidelines. If you have legacy material, you use display refer conversion. If you have live production, you use scene refer conversion. Very important to obey these guidelines. All right, at the show, we are introducing two new devices or family of devices for mastering in HDR. This is a new monitor, the HX310, capable of 1,000 nits across the entire screen with perfect temperature control and uniformity. It has a 1,000,000 to 1 contrast ratio, and it has a 12G input, and also has the capability to show you quad view. It has 4 display engines inside, and we can allocate different lots to each one of these quadrants. I can have 709, 2020, S-Log3, HLG, totally independent in our monitors. Now, but this is an expensive device. This is for post-production and mastering environment. For field production, we are now introducing a very cost-efficient display, the family of the A240, A220, A170. These are on-set grading monitors that has now, because of a free upgrade software, you can play all of the HDR curves that are available in the market. Very low cost. The brightness is relatively, it's about 400 nits, and it's very easy to use in field production. All right, just to conclude, this is the entire gamut of products that Sony has created for professional applications, all the way from cinematography to live actions. And we have now a very, very strong knowledge of HDR, SDR live production. You will see, right after this presentation, some clips that were captured in 8K or 4K using these techniques that I just explained in this presentation. Thank you very much.